Now let's look at the data from another perspective, categorical versus quantitative. I already talked about this briefly. So data can be further classified as being categorical or quantitative. And under categorical, you have nominal and ordinal. Under quantitative, you have ratio and interval and ratio. Now, another way of looking at quantitative data is to see whether it is discrete or continuous. Now, discrete is when you have specific values that are countable. For example, how many customers will arrive in your store per day? So you may not have anybody arriving at all, so it will be 0, or the next value will be 1, and then 2, and then 3. So you can keep counting, and there cannot be any value between 0 and 1. You cannot have half a customer coming in. So discrete here means countable, as opposed to continuous, where the possible values can be any number between a lower limit and an upper limit. Let's take the same example as customers arriving in a store. So instead of counting how many customers are arriving in a store, which would be discrete, now instead, if we want to measure what is the time between arrival of two customers. First, one customer comes in, and what is the time it will take for the next customer to arrive. Now that value is not countable because it can be any number greater than or equal to 0. Okay, the next customer may arrive right at the same time, in which case the inter-arrival time between customers is 0, or it could be a positive value which is greater than 0, but you cannot say it will be like 0.1 second or 0.001 second or 0.0001 second. Okay, so when you have continuous measurement, so that means you can only specify what will be the lower limit and what will be the upper limit. You cannot say, okay, this is going to be one of these possible numbers that you can count. So quantitative data can be a discrete quantitative data, or it can be continuous quantitative data. So here in this chart, we have all the different types of data organized. So we have data classified as categorical or quantitative. And if you take categorical, it is usually a label, non-numeric label, but it may appear as a number. Okay, you can have numeric codes, and even though they have a numerical appearance, they are still categorical. And in each of those cases, you can have nominal or ordinal. The quantitative data is always numeric, and they can be interval or ratio. Now, when you collect data and do analysis, and you can do this in two different ways. One is cross-sectional data. Cross-sectional data is like a snapshot. The data are collected within approximately a small period of time, and it represents the concept that we are measuring at that moment in time. That's it. So here is an example, data detailing the number of building permits issued in November 2012 in each of the counties of Ohio. So then you have data for November. That's it. That's a snapshot. Or you can have time series data collected over several periods of time. So if you do the same thing, the number of building permits issued in a particular county or for the whole state of Ohio, okay, over a period of time, November, December, January, February, and so on, then so when you record this data over several periods of time repeated, then what you have is a time series data. So you have cross-sectional data and time series data. Cross-sectional data are very useful in understanding the underlying concept. Time series data is very useful for prediction purposes, for forecasting what the future values will be. So here is an example of a graph of a time series data. So time series data can be graphed with time on the x-axis, and you can visually see how the data is moving over time. Now, what are the sources of data? So you can have sources that are internal, already existing data in the company records. Almost all departments collect data. So you will have an existing source of data. Okay? Or you could have government sources and business sources, industry sources that are external to the company, and they collect data and organize data and make it available for people to use. So you can get data from existing sources, both internal and external. The data available from internal company records or examples are some of these: employee records, production records, inventory control, and so on. Now, external sources like government agencies, we have Census Bureau and Federal Reserve Board and so on. So these are sources of data available from outside the company. Now you can also gather data by conducting an experiment or conducting a survey. So here we can look at collecting data in two different ways: experimental analysis, data for experimental studies, and data for observational studies. In experimental studies, we'll be controlling the variables in one form or another. For example, if you want to look at salary difference between male and females, you cannot simply collect data of n number of female graduates and n number of male graduates and then see whether there is a difference. And it may tell you something, but it is not controlled for other factors that may have an influence on salary. So what about GPA? That may have an impact. What about experience? And what about the university from where the person graduates? So there are other factors that may impact the value that you're studying. So you have to control for those factors. So if you actively control the other factors that may have an influence on the concept that you're studying, then that is an experimental study. As opposed to an observational study is one where you simply take data as is and do not control for anything. So a survey is a very good example. So studies on smokers and non-smokers are usually observational studies, because you cannot make somebody smoke and somebody not smoke and control their characteristics. So observational studies are data that you observe as is without you being able to control, and we will control the elements, and we will look at the differences in chapter 13 when we get to that chapter, obviously. So data acquisition consideration, you have to look at what is the time requirement, cost of acquisition, and data, the possible errors that may appear in data, and also what is the benefit that we're going to derive from this study. So usually external data, if it is not from a reliable source, may contain errors, and you have to make sure that those errors are caught and removed from the data set. When you have a data set, then you can do descriptive analysis with the data, and there are two different kinds of descriptive analysis you can do. One is a presentation analysis, like graphical presentation or frequency distribution, histograms, and that kind of stuff, or numerical descriptive statistics like average and percentiles and quartiles. So we'll be studying these two types of presentations. In chapter 2, we'll study the graphical and frequency distribution type of descriptive analysis, and in chapter 3 we will be looking at the computational descriptive statistics like average and so on. Now, statistical inference, this is the topic of chapter 8 through the rest of the book. So you have a population which is of interest. For example, starting salary of business graduates. Now you cannot take this data from the entire population, so you take a sample, a subset of the population. Then you study the subset, the sample, compute the average, do hypothesis testing, do confidence interval, and so on about the population. So from the sample, you're trying to understand what the population will be like. And that process is called statistical inference. Now, census is when you collect data for the entire population. So if you collect data for the entire population, then there is no inference needed because you have the entire population, and whatever descriptive statistics that you compute, the average and so on, they represent the entire population. So in the case of census data, there is no statistical inference necessary. Only when you take a sample, then statistical inference becomes necessary. Now, computers and statistical analysis, with the increasing power of computer and the ubiquitousness of data collection like your smartphone and other scanning technologies, there is immense amount of data that are being generated every day, and so analyzing, capturing, analyzing the data and making sense out of that data has become extremely important, and that has spawned a new area called data analytics, which is actually statistics for huge data sets using advanced statistical software packages like SAS or SPSS and so on. And we are offering from 2015, I think, data analytics concentration, a major a concentration in management major. So there will be business analytics that's coming up. This is in the process of approval, and I think if it goes through, we'll be offering that concentration starting fall 2015.